Our current understanding of the cosmos is often framed as a recent achievement, a story of steel telescopes, deep space probes, and computational astrophysics developed almost entirely within the last few centuries. We trace the foundations of celestial mechanics to a handful of specific figures, primarily Johannes Kepler and Isaac Newton, viewing them as the originators of the laws that govern the stars. But the historical record contains a massive anomaly. Thousands of years before the invention of the telescope, scholars in ancient India were publishing advanced celestial mechanics that align with our modern observations. These ancient texts described a spherical, spinning Earth and correctly modeled the synchronized orbit of the Moon, explaining exactly why we only ever observe one side of its surface from our position on the ground. How did a pre-industrial civilization calculate these physical laws, and why do these breakthroughs remain a footnote in the standard history of science? The answer lies in the transmission method. To preserve massive amounts of complex scientific data across millennia, Indian scholars compressed their findings into rhythmic Sanskrit poetry, allowing the information to be perfectly retained through rote memory. To understand the extent of their knowledge, we have to look past the poetic structure and analyze these texts for their quantitative scientific observations. On the terrestrial scale, humans spent centuries struggling to grasp relative motion. From a stationary point on the ground, the physics of a moving object can feel fundamentally different than our own. In the 1600s, Galileo illustrated this with a boat analogy. He proved that for anyone moving at a constant speed in a straight line, the mechanical laws of physics remain identical to those of an observer at rest on the shore. 1,000 years before Galileo, the Aryabhatiya used this exact same logic. Written in 499 AD, it explained that just as a person in a boat sees stationary objects on the bank as moving backward, we perceive the stationary stars as moving across the sky. Then there was gravity. For much of human history, a force that could pull an object across empty space without physical contact was seen as an impossibility. Detailed explanations of this force appear in the commentaries of Adi Shankara, who analyzed the Vedic Upanishads more than 1,000 years ago. Adi Shankara explicitly stated that the Earth attracts everything placed upon it. He described a universal downward pull that keeps the atmosphere and all physical bodies from flying away into space. These fundamental laws were already being modeled with mathematical precision in India long before they reached the Western scientific record. Widen the scope to the solar system, and the gap in knowledge becomes even more striking. European astronomy spent 2 millennia committed to a geocentric model, believing the Earth sat at the center of the universe. The Vedic model, however, was heliocentric. It described the sun as the attracting power of all heavenly bodies, holding the Earth and other planets in place from all sides. Traditionally, we credit Johannes Kepler with the discovery that planets do not travel in perfect circles, but in stretched elliptical orbits. Yet the Vedas contain a geometric construction called the Trinabhi chakram. It describes using a rope and focus points to plot an ellipse. The texts apply this geometry to planets, describing their imperishable elliptical paths. Their steady speed ensures solar system stability. Centuries before the invention of telescopes, Indian astronomers deduced the precise geometric shape and orbital stability of the planets using pure mathematical logic. Finally, there is the ultimate limit of physics, the speed of light. This was a measurement that modern science struggled to pin down for over 300 years. Through physicists like Albert Michelson and the refinement of lasers, we froze the speed of light in 1983 at roughly 186,282 miles per second. But a calculation that closely matches this figure appears in a 14th century commentary by Sayanachyarya. Sayanachyarya calculated that light traverses 2,200 yojanas in half an amisha. Based on historical units, a yojana is approximately 9 miles, and an amisha is about 0.2 of a second. When you crunch those numbers, the resulting velocity is 185,014 miles per second. This 14th century calculation, preserved in prose, lands within a fraction of the 186,000 mile per second limit finally verified by modern scientific instrumentation. This evidence forces a reconsidering of ancient Indian civilization. they weren't just philosophers. They were rigorous observational scientists who built mathematical models of the universe. Even their cultural icons reflect this. The Nataraja statue of a dancing Shiva is a physical representation of complex dynamical structures and cosmic mechanics. Modern scientists have noted this connection as well. A Nataraja statue was presented to CERN, the home of the world's most advanced particle accelerator, because its symbolic dance mirrors the behavior of subatomic particles. The history of human knowledge is not a clean, linear timeline. It is a fragile record where vital scientific data was often stored in rhythmic verse to ensure it survived the rise and fall of empires. When you look up at the night sky, you are observing the exact same mechanics that ancient scholars brilliantly decoded and preserved in their poetry thousands of years ago.